Next, we will lay the foundation for developing a procedure for testing statistical claims. Let's start with the definition of a hypothesis. A hypothesis is a testable claim that is either true or false. For example, someone may claim that Earth is round. To test a hypothesis means to verify its truthfulness in a scientific way that is universally acceptable by both the opponents and proponents of the hypothesis. How would we test whether Earth is round or not? We may send a sailing expedition that travels only west, and we would agree that if the sailing expedition comes all the way around, then Earth is round, and if the sailing expedition falls off the edge of Earth, then Earth is flat. By the definition, the hypothesis can be either true or false. Testing the hypothesis may also result in two outcomes. The test will either confirm or reject the hypothesis. In case when the expedition sails all the way around, the true hypothesis will be confirmed. In case when the expedition falls off the edge, the false hypothesis will be rejected. If either one of these scenarios was to happen, then the testing procedure would serve its true purpose of figuring out the truth. But is it possible that something goes wrong? What if Earth is round, but the boat falls off Niagara Falls? Then we would believe that it fell off the edge of Earth, and for a wrong reason, we would have to reject the hypothesis that is true. On the other hand, what if Earth is flat, and the expedition only sailed around the continent due to a compass malfunction? Then we would believe that it sailed around Earth, and for a wrong reason, we would have to confirm the hypothesis that is false. If either one of these scenarios was to happen, then the testing procedure would return the wrong result. No matter how perfect the testing procedure is, there is always a chance of making an error. Rejecting a true hypothesis is called type 1 error. Confirming or failing to reject a false hypothesis is called type 2 error. The difference between the two types of errors is clear and depends on the context. Consider the following example. When a suspect is brought to a trial, they are either guilty or not. And there are two outcomes of the trial. The suspect is either convicted or cleared. You can clearly see the difference between the two types of errors, as it is not the same to clear the guilty and convict the innocent. At different times, different justice systems may prioritize one type of error over the other one. In the testing procedure that we will develop, we will set a maximum threshold for type 1 errors, and we will call it alpha, the significance level. In statistics, we'll learn how to make and test statistical claims. Definition. A statistical claim is a statement about a population parameter in the form of an equation or an inequality. For example, the average height of students is less than 170 centimeters is a statistical claim about the population mean, and it can be expressed symbolically as mu is less than 170. The proportion of females on campus is more than 60% is a statistical claim about the population proportion, and it can be expressed symbolically as p is greater than 0.6. The student's GPA variance is 1.21, is a statistical claim about the population variance, and it can be expressed symbolically as sigma squared is equal to 1.21. The company's average salary is different from the state's average of 67,565 is a statistical claim about the population mean, and it can be expressed symbolically as mu is not equal 67,565. Soon, we will develop a formal procedure to test statistical claims.